Welcome to Math 154 videos. This video is going to go over the logarithmic differentiation technique. So for a problem like the one we have here, where it's really hard to just take the derivative, we're going to instead take the natural log of both sides first to make the problem a little bit easier. So that's what we're going to do in this case. After we take the log of both sides, we can bring the power down into the front, because the log can change our exponentiation into a product. So this is going to make it way easier for us to take the derivative of our function. So now we have the natural log of y is equal to tangent of x times the natural log of x. Well, now our right side is just a product rule, so we can take the derivative of both sides with respect to x. So on the left side, that's going to become an implicit differentiation. So we're going to go ahead and take the derivative of natural log of y with respect to y. So that's going to be 1 over y. But then y is actually a function of x. So we have to multiply this, because of the chain rule, by the derivative of y with respect to x, which is y prime. Or if you wanted to denote that dy dx, the derivative of y with respect to x, that's okay too, however you want to denote it. They're the same thing. So then we go to the left side, and this is just going to be a product rule. So we're going to take our first function, tangent of x, and we're going to multiply it by the derivative of natural log of x, which is 1 over x. Then we're going to add to it our natural log of x times the derivative of tangent of x. Well, that's secant squared of x, if you remember your derivatives of your trig functions. And now what we want, implicit differentiation tells us we need to get y prime on one side by itself. Well, it's almost by itself. We have this 1 over y here with it, so we're just going to have to multiply by y. So we'll get y prime is equal to y times the tangent of x over x, and we'll put this whole thing in a big parentheses, plus the natural log of x times the secant squared of x. And there you have y prime. That's what we wanted. But the one thing you can notice is up here we have y explicitly defined as a function of x. Y is equal to x raised to the power of the tangent of x. So we can actually substitute that back in for y. So we're going to do that. So we'll get y prime is equal to, well, our y is x raised to the power tangent of x, then times tangent of x over x plus this product that we had here before. And so that is going to be our final derivative. And you're always going to want to make sure that if you can substitute that function of x back in for y, that you do so before you finish the problem. And that's our derivative. So here's our second example, and we're going to approach this the same way by taking the natural log of both sides first. And that's going to take this exponential up here, this 1 over x, to product, so we'll get the natural log of x here. And now we have two things multiplied together on the right, so that turns into a product rule, and we'll use implicit differentiation on the left. So when we differentiate the left side with respect to x, we get a 1 over y for the derivative of the natural log of y with respect to y, but then we have to multiply that by the derivative of y with respect to x, which is dy dx, or y prime. And now on the right side, we're going to use a product rule. So first we will take our natural log of x, and we're going to multiply that by the derivative of 1 over x. Well, you can think about that as x to the negative 1. So we're going to multiply by a negative 1, so we'll put a negative out here, over our x. Well, negative 1, if we decrease the power by 1, that becomes a negative 2, so this becomes an x squared in the bottom. And now we're going to go ahead and do the next one. So 1 over x, and then times the derivative of the natural log of the natural log of x. So first we take our outermost natural log, that's this one, and we're going to take 1 over whatever is inside of it. So what's inside is the natural log of x, so we get 1 over the natural log of x. Then we're going to take the derivative of our innermost natural log. Well, that is 1 over x. Alright, so we can go ahead and write this. We'll write y prime on one side, and then we can move our y to the other side. We have the natural log of the natural log of x all over x squared plus, well, this becomes 1 over x squared times the natural log of x. And we're pretty close to being done here. We need to take this y is equal to the natural log of x raised to the 1 over x power, and we're going to need to substitute that back in. So we'll get y prime is equal to, our y is the natural log of x raised to that power. Here we could pull out a 1 over x squared, but I'm actually going to leave it because I think it looks a little bit nicer here. So we'll copy down everything. And that's going to be our final answer for the derivative.